Testing should be live. Share my screen, pull up a couple things on my end, and we're a couple minutes early. So hopefully some people will roll in here. And as you're joining, say hello in the chat. Oops. And sometimes there's a little delay from when I talk to getting to the stream. So I'll go into what this event is if you haven't been to a book club before in a minute, but I'm going to wait until the start time or a couple minutes past just to allow people to join in. And also while that's going, let me just make sure that links are in the right places and stuff like that for this event. I make sure I posted the right live stream link in the meetups. Cool. I think so. Just never know. I know I've messed that up, I think, once before, or I thought I did. And then also, I'll just mention if, let me pull up another link real quick. If you found this on Meetup or Luma, there's a couple different places that it was posted in. I gotta bring up the LinkedIn live stream to share links in there. If you want to RSVP on Luma or join the calendar there, if you found this some other place or just joined in on LinkedIn Live, you can click that link in the chat. That's going to be the best place to kind of stay opted in. And again, if anyone's here, I can't see who's watching on LinkedIn, say hello in the chat. And let me, I don't think I need to present. I think this will probably work okay. Then we'll wait another minute or for someone to say hello in the chat, and then I'll go through. And again, if no one, or usually there's quite a few people that end up coming to this. If it's a lower turnout or just quieter today, which I always think might happen, but then a lot of people join in or join the discussion and come up here, which if you want to come and join the actual live stream here, I will share a link in a minute. Actually, I could probably share that out. While we're waiting for people to join, I'll probably share it a couple times. So if you actually want to come up and join the stream, I'm going to share it in LinkedIn. If you're watching on another platform, you can find me on LinkedIn and message me there. And then we'll get going. Cool. I see a couple people in the chats now. Awesome. Let me just grab this one thing, like I'd mentioned, the invite link. And this is for if you want to, again, come up and join here with your voice or video. You don't have to turn on your video if you just want to do audio. We used to do audio discussions back in the day before LinkedIn killed that specific just audio feature. So now we do this live stream. And you can join there if you want to come up. Otherwise, talk in the chat. Most people end up just talking in the chat, and that's totally fine. What I'm going to do is do a quick intro to the event, and then we'll go through just kind of like chapters of the books. And this is a open discussion. I have some slides here, but it's not like a massive presentation on the topic. It's meant to be more of an open forum discussion, and that happens again in the chat, or if you want to come join here. And also, if you want to share stuff outside of the book, but that's related to AI and LLMOps, usually that happens a lot as people are like putting stuff in production and have these types of questions during the events. And honestly, I think that's the most fun part, is just hearing what other people are working on and challenges you have. And that usually relates into the topics of the book. So I'm going to go ahead and get going, and I'll share in the chat as well. The link to this book is LLMOps. If you haven't checked it out yet, you can go do so there. This is the AI book club. So in short, we just read a new book every month. This originally wasn't a new book every month a long time ago when I first started a version of it. And then the last 2 years now, almost, we've been doing a book every month. We did it last year, and then we're going to do it this year. We'll see if we continue that in 2026. It's a lot of reading, but there are a lot of really cool books coming out. Also, if you want to join the Slack channel, and potentially discuss in there as you're reading the book or ask questions. You can join the Flight Slack channel. That's Flight is an open source MLOps project platform that I actually work on. You can check that up there. And again, if you want to join the audio discussion, you can message me, or I shared the link in the chat here. And then we do have a GitHub repo that I need to update with the most recent book. But if you want to do like pull requests there or request books there, you can as well, because I definitely want to hear what you want to read. And then one last link, again, if you want to really stay in the loop, joining the Luma calendar is probably the best way to do that. I'm going to post every event that we do there, as well as other events in the future outside of book club. And then the schedule for 2025 so far is this. We've read quite a few books. Now we're getting into the last few months of the year, which we're in October. We read LLMOps. Next month, November, we're going to read Deep Learning for Biology. I'm kind of excited to go into a very different field kind of than the last several books that we've read that were really LM focused, which I'm not sure if people are burning out on that. So if you have other book recommendations, let me know for 2026 if we want to diversify it more. I tried to throw some stuff in that isn't LLMOps or LM related, but obviously a lot of new books that are interesting are coming out around that. And then in December, we're going to read Building Applications with AI Agents, which I'm excited. I think I've heard that was good. It just came out, so there weren't a lot of reviews, and I haven't really skimmed the whole book so far. But let me know what you want to read next. So we're booked out for the year. But if you have ones in 2026, again, there's a ton of new ones coming out all the time. I'm kind of monitoring what is coming out and when, and they'll go into a list. And if you join the Slack channel, I'll usually post there, and people can kind of vote on what we'll read next sometimes. Some people have also asked for more general machine learning books again. So maybe for the first month of 2026, we might do something a little more foundational in like deep learning and machine learning, if that's interesting to people as well. Let me know. And then this format, again, I saw someone join in. I'll let you join the audio here in a second. But just want to say, again, talk in the chat. If you want to join the audio discussion, let me know, or I shared the link previously, and I'll probably share it again here in a little bit. And then I wanted this open this up before we go into the next slide, which is all the chapter titles. I always like to say, if there's shout outs from anyone in the community, if you want to put in the chat, or again, if you're joining up here, is anyone hiring? Is anyone looking for a job? Do you have any awesome projects you're working on that you want to share? Let me know in the chat, or again, if you joined the audio here, and then I'll let people up in a second that did request that. The one thing I will share right now, let me go get the link real quick, is we're hiring at Union. So I'm going to get the job board there and put that in the chat. If anyone wants to take a look at what job openings we have, definitely encourage you to apply. I think we should have a lot of engineering roles. I need to go look again exactly. Right. And with that, again, I'll open up, so you feel free to post stuff in the chat if you want. And let me let this person up. Hello, hello. Is it Bharat? Am I saying that correctly?
Yeah, hi. Can you hear me?
Yep, I can hear you. Welcome.
Yeah, hi. How's it going?
Good. How are you doing?
I'm doing good. I'm good. It's my first time sort of joining your live stream here.
Cool. Welcome.
Yeah.
And what I'm going to do is I'll unless you have something right away, I'll read off the chapter titles of the books of the book. And I don't know if you read the book at all. A lot of people haven't read the book. That's totally fine too. And we just kind of discuss the topics loosely. And if you want to add questions or like your personal experience, I think that's when a discussion is really valuable. So I'm not sure if you had anything right off the bat that you wanted to mention, or a shout out, like if you're hiring or looking for a job or anything else like that, before we get into the chapter contents.
No, I think it looks good. I'll just stick around to it. Right now, I'm just looking for an internship, maybe something to work on it. I was working on MLOps before, and it's exciting to sort of also learn more about LLMOps as you sort of proceed to it.
Cool. What kind of MLOps projects have you done or have experience with?
So I was essentially like taking a course where it was kind of like a project-based course where we were making a crypto-based prediction system, and then given the patterns of maybe previous data indicators, etc., and sentiment analysis, using all of those things, using a machine learning model on top of that, making sure that the inference was run on fly, and the model itself was continuously trained, deployed on a dashboard. Um, and yeah, pretty much that. Like a lot of tools, I think I learned along the way. It wasn't like the most accurate like hedge fund trading system, but I think I learned a lot of tools along the way in terms of handling data, using sentiment analysis for using LLMs. I think, and sort of using Grafana for sort of visualizations, etc.
That's cool. That sounds like a cool project of touching a lot of different areas of the kind of MLOps or LLMOps stack. Did you have like one thing that you thought was like the most challenging part of that, like putting an LLM or model in production?
Yeah, I mean, I think it just kind of killed my laptop also in some way. So just making sure that running those things, I think, in a resource constrained environment was definitely one thing. But however, like I think it was better than learning. So I'm in university right now, and I think I sort of also learned core ML and machine learning, and I think it was a bit easier in that way, like from engineering point of view, using different tools. So I think and the background sort of really helped also in some way. But I think it's more so like understanding the tools and different things. You just really have to make sure that you spend time in debugging and understanding what it is. So if it was like an hour-long course, it really took me like 2 hours, 3 hours of coding work for me to actually get good at it or really
Awesome.
understand. Yeah.
That's very, oh, and one last thing before I'll go in the chapter titles here. Oh, you said you're in university right now. What are you majoring in?
So I'm majoring in computer science and AI right now.
Very cool. Exciting.
Yeah.
What an exciting time for it.
Yeah. So what about you? Right? Like, are you like a learner right now, or are you also working somewhere? Because
Yeah,
it's my
I'm
first
working
time.
at,
Sorry for this. Yeah.
oh yeah, no worries, no worries. It was great. I'm working at a company called Union AI. I shared the link in the comments because we are hiring, like I mentioned. So if anyone else is hiring too, wants to throw out their job links, do that in the chat. It's always kind of fun, see who's hiring, especially right now. I know there's, I think, a lot of layoffs going on this week. It sounds like in the industry from some of the big players anyway. So always happy to share or have people share like their hiring links. All right.
Perfect. Thank you so much. Yeah. I'll stick around. Thanks.
Oh yeah, and feel free to join in. It's more fun if someone else is up here talking, not just me. So usually people come up and join the discussion. I'm going to read the chapter titles, and then I can go a little bit into each chapter. So we have number 1 is Introduction to Large Language Models. If you've done any other content or read some of the other books that we've done, this might feel like you've probably read a lot of this before. But again, a good kind of introduction to the field if you haven't read that before. And then we did introduction to LLMOps. So a little bit, how do you manage LMs in production, and kind of a high level of the things they dive deeper into other chapters. Chapter 3 is LLM-based applications, where you would use LMs. Again, you might be familiar with this. I liked in the LM, I think it was the LLMOps chapter. I had a couple notes, so we'll get to those later. I think it was the LLMOps one. One thing I did appreciate is kind of they had a good approach of describing it, which I don't think a lot of the other books we've read went as deep into some of this. So they describe some of it kind of from the perspective as like a reliability engineer, like on the software side. And I thought that was kind of cool. Like it makes sense if you're doing this at a big company that you would think about things that way. And we can go into that a little bit later, I think. Chapter 4 is data engineering for LMs. Chapter 5 is model domain adaptation for LM-based applications. It's like getting a model to work in domain-specific areas. 6 was the API first LM deployment. 7 was evaluation for LMs. I always love reading the evaluation chapters because I always think that's such an interesting space right now. They also had like a whole bunch of different metrics and tools they pointed to, some of which I hadn't heard of before. I used to work in this space, and then I try to keep up to date a little bit, at least with like some of the big players like Arise and Weights and Biases. They have some really cool tools for it. And there are some other metrics that they pointed to and open source tools that I wanted to go check out after this. And maybe I'll go get those and share those in Slack later too. And then 8 was governance, monitoring, privacy, and security. They did go they touch on like security a fair amount in the book, which is good, I think, to think about for LLMOps. And then scaling hardware infrastructure and resources. And then chapter 10 was the future of LMs and LLMOps, which is kind of like closing and where they think the space might go, and if you're going to become an LLMOps engineer, how you should think about maybe the future. Let me catch up on chat here real quick. Someone said, will running the code that LLMs generate be the top case for production and not the LLM itself? I'm not sure I exactly understand the question. Will running the code that LLMs generate be the top use case for production? Does that mean, like, is that going to be the top LLM use case? It's just like code generation? Is that the question? I mean, it's a big one right now, and a lot of the people in the industry are probably doing that. But I think there's going to be a lot of other use cases too, like distilling a lot of knowledge in documents is a huge one. Like you see this come up all the time with like law, for example, because you're usually going through so much text. I'm not 100% sure if that was the question. If the code is going to be the actual production use case and not the LLM itself. Which, maybe you're asking like, how do you take the code that is generated and put that in production versus like putting the LLM in, because that's what most people are using it for. That might be what the question is, which is a good question too. Like you would want to build a pipeline, which I mean, code pipelines have been around for quite some time. And you want to build a pipeline that can make it easy for you to get that code out in production, might be what you're asking. We also still want to evaluate that code, write tests for it probably, especially if you're just having LM generate and you're not really reviewing it. Something like that would be probably very good. Sometimes you want to run that code in like a sandbox environment first for those testings where it can't mess up your production in any way. And someone asked, is LLMOps like DevOps? Yeah, it's DevOps for LLMs. There's some specific things that are a little bit different about large language models in production versus typical machine learning models or code like DevOps area. So one is like the evaluation piece. Like I said, these chapters are always really interesting because a lot of the times the output of a LM is subjective, not really an objective measurement where you could say like, did it fail? Did it pass? Sometimes it is. A lot of times it's generating like a summary or something else. There's all these different metrics you can use to get like a good idea of the score, or you have to have like a golden data set and review that every time you do that. And then you have different pieces that go into your LM. Like you have prompt management, you have the data set that you fine tuned it on. There's different post-training fine tuning things as well. Keeping track of all of that so you can debug it and then get that model out in production. And then there's also like, that goes into this book, a lot of optimization methods for LMs that are a little bit different than other models. Like you still have things like quantization and pruning. There's also like you can fine tune a LoRa adapter, which is a low rank matrix. I forget exactly. Is it low rank? I forget what it stands for. Low rank something matrix, where instead of fine tuning like a massive, huge model that has a ton of weights that can take a lot of compute, you can fine tune a piece of it that you can insert in there and then get good results from it. And then there's also optimization things like they mentioned here, like KV cache, where you're caching like the query and the prompts that people are asking those LMs. And also you can do that with embeddings. And there's a lot of stuff on the LLMOps side too that I think they talk about in here that covers like RAG and creating RAG pipelines as well. So it's like DevOps, but there's very specific, and MLOps, but there's very specific things around LMs. And now they have this new term, LLMOps, that kind of tries to cover all those specific things that are a little bit different. And they talk a lot about like governance and security and privacy in here too, which is a big deal, where you probably don't want your LM leaking any knowledge that it was trained on. And you also don't want it leaking any knowledge. Again, if you have stuff in a RAG system where it's pulling in information from somewhere, but you don't want to have it like return social security numbers or credit cards probably a lot of the time, right? So there's a lot of stuff to think about for LM specifically, and they can behave pretty weird sometimes. So it's really good to have some sort of monitoring system and then think about all the other kind of use cases. For the person who asked that question, have you done DevOps before? And are you looking to get into LLMOps? And Elsa said VLM with KV caching. Yeah, VLM is actually, let me pull that up. I like to bring in notes too, and I'll share the slides. Actually, I could probably do that here. Let me make some notes though, or I'll just grab a link to that. People haven't checked out VLM, you should check it out. It's a great kind of serving framework. And I'm going to add tools and stuff that people mention into a note slide here. And let me share this. 1 second, everyone. Anyone with link can view. And I'll grab this. And if anyone wants to come back to this, again, there's not much in the slides here. But if you want to grab these notes later, I will share the link here, and I'll share them in the Slack channel later as well. I think they mentioned VLM in the book, but they also mentioned VLM as in like a visual language model at some point too, and that they spelled it the same way, which usually you don't.
So I have a question.
Yep.
How different would it how different would training or fine tuning of VLM than would be than training a LLM?
A good question. I actually haven't done like a fine tuning type of thing on a VLM yet. I've done it on like LMs. For the VLM though, usually, and someone else in the chat correct me if I'm wrong. You should go look this up because, like I was saying, I'm not an expert in it. But I think what I've seen is you're often training that with text, like a caption type thing for the images. So you get like these embeddings that come from the text describing the image. And I believe it learns from looking at the image and the embeddings for it. But someone correct me if I'm wrong on that. And we should look it up actually maybe right now.
So it's essentially the pre-processing step where you convert an image into its individual embeddings and then pretty much the similar things from there.
I think something like that. Let's look it up. Let's see. I'm trying to remember where I even was looking at an example of this. I think I was seeing an example of a diffusion model, actually, which maybe is what I'm thinking of, which might be different than the visual language model. Because I think I was looking at how to train a diffusion model, which might be slightly different than the visual language model. So you might do something similar, because I assume you still have to have like text related to the image in there. But it's a good question, and this is why the book club's fun. We can find out different answers. Oh yeah, because they had I know that, well, there's clip embeddings which I believe were trained a similar way. Let me find out. Again, I don't want to make stuff up, but I'm pretty sure I remember reading like the clip paper a long time ago. Let's see. And if anyone knows in the chat, let us know. Yes, I think you need a vision encoder and decoder, so similar to the encoder decoder model, but it has to change the image format. I'm pretty sure to something. Data you need is image text pairs, I think, is what I'm seeing for the pre-training stuff. And then you can, I guess, maybe add some other fine-tuning pieces with like object detection in there potentially. I think there's different ways to pre-train it. So if someone, if you've done it before, add more in there. But I'm pretty sure it's like a vision text pair a lot of the time still. Said, oh, a lot of people also fine-tune vision models via diffusion. Yeah, because I remember looking or doing like a diffusion course a while ago, and that was the data set in there. And I think I also like looking at the clip and what was the other one, blip papers a long time ago. But we should look up. I should add it to my list to fine-tune a vision language model. But I'd assume it has to be that pairing. Also, let me grab the link again that I'll share if anyone does want to join in the chat here. I'll share it one more time. That link I just shared, the StreamYard link, is if you want to come join the audio and video. And Kevin said LLMs are hard to train fine-tune on limited resources. Yeah, it depends on what you're fine-tuning for too. And if you want to use a method like LoRa or not as well. There's also fine-tuning for like the output and behavior, like with reinforcement learning, like the GRPO type of stuff that I think like DeepSeek, I think it was DeepSeek uses GRPO, and I know it uses reinforcement learning. I think it was GRPO, which is the method for kind of post-training, or a lot of times people do it in post-training to reinforce kind of the behavior outputs that you want from your large language model, which is different than like your big pre-training on like the giant corpus. All right, so I'll go through some of the chapters. Great question. And actually, I'm going to write this down as a question. It's a question. Maybe we'll look this up later. Training a VLM. All right, so the first one, again, I'll kind of recap here. So if anyone wants to jump in with questions or comments, let me know. Chapter 1 is the introduction to large language models, and the sub chapters or things in here was some key terms. Again, probably terms everyone here is talking like they've interacted with some LLMs somewhat. So terms you probably are familiar with. Talking about the transformer model, large language models, LLM architectures, choosing an LLM, enterprise use cases for LLMs, 10 challenges of building with LLMs. I actually forget what those 10 challenges were. Let me see real quick what they mentioned. Unless anyone else remembers. They say size and complexity, training, scale, and duration, prompt engineering, inference latency and throughput, ethical considerations, resource scaling, and orchestration. That's actually the field that like we work in at Union. We have an open source project called Flight, like I shared the Slack channel for it, that a lot of people use for the orchestration layers and resource scaling. Like LinkedIn actually switched all their large language model workflows to using Flight, which is cool. I'll share a link to that if people are interested after I finish up the 10 pieces here. And then 7 is integrations and toolkits, broad applicability, which I think that just means like it has a broad applicability, but actually getting it to work is probably one of the challenges. 9, privacy and security, and then 10, costs. So I don't know if anyone's run into some crazy costs yet or anything by burning a lot of tokens before as well. And Kevin said the best method they found is multi-LM orchestration, hot swap top LMs as needed to scale through progressively larger problems. That sounds great. Yeah, I think we're seeing more of that, and I think that even I don't know for sure what all the systems look like, but that's kind of the rumor somewhat of that's how GPT-5 is that you have a router model and then it chooses the best model for the type of question. And I think that might be kind of what you're talking about too, Kevin. We have a multi-LM orchestration, you hot swap the top models, unless you're manually hot swapping, which I guess you could be doing as well. But this is pretty common now too, as you're building like agentic systems where you have a router type of agent that could be using whatever LM you want, or one that you fine tune for routing. And then you can choose to route to the right task, which could be a different model, or the same model with a prompt or some variation. And I think we're seeing, I don't know if anyone's like fiddle around or put agents in production, but one of the cool things about building agentic systems like that is being able to hot swap things in and out and like test different models out. You could even do A/B testing if you have a lot of users and see which one is better. And you even see this a little bit with like if you use ChatGPT, sometimes you'll get those 2 responses and ask which one you like better. I think they use that data to either fine tune a model better, or they're already testing another model and seeing which response you like better from those. Or another model is in like it's the same foundation model, but with probably some different output fine tuning or prompt. And you can hot swap prompts as well. So that's really interesting to experiment with, and what most people start experimenting with from people, the people that I talk to. Oh, and let me pull up GitHub real quick. So if anyone is looking for an orchestration layer too, you should check out Flight. It's one of the most commonly used open source orchestration platforms right now. Obviously, I'm biased because I work at a company that works with it a lot, but it's super cool, and you should check it out. And if you're interested in putting stuff in production and you want, actually, a lot of the stuff this book talks about in some of the chapters, like orchestration, compute scaling, caching, those are all kind of things built out of the box in Flight. That's super useful. And it's interesting seeing the common pipeline issues that you might experience from building an MLOps pipeline. So actually, even the project you potentially worked on with the crypto trading, if you like ran into issues like caching and stuff, for example, just in your training pipeline, where it's like you want to, if some step fails, you want to recover from it. A lot of the stuff translates over to LLMs and LLMOps now, which is interesting. So if you're doing like an agent system, not even just fine tuning an LLM, but if you're doing like an agent system and you have a planning agent or routing agent, I would say planning agent, that's like spending a lot of time relatively to come up with a plan for how to run the agent workflow. And it spends all those tokens, which can cost a lot if you do over time. And then also the time can kind of cost a lot, like to your user, or feel very long. And then if it tries to do a tool call or something like that on an API, those fail sometimes, right? And so you don't want to go back from zero and do the whole planning process again. So actually having caching in your pipeline, just like you've had in like more traditional pipelines, really translates over to a really useful application in like agentic MLOps too, which is really interesting. So like all that kind of stuff, you can pull over to LLMs and usually find it very beneficial in your pipeline or agent workflows.
Yeah, sounds very interesting.
Chapter 2 was Introduction to LLMOps. What are operational frameworks? So they talk about some frameworks internally to a company, like teams and roles. They have SLOs. I forget what SLO is, and SLAs and KPIs. So basically the goals you want to define for your LLM, like what kind of impact is it going to have on your organization? I forget what SLO stands for. Is that, someone remind me in the chat? Service level objectives. So if you want to be specific and measurable and target and have a target set by an organization. So basically you're using this to like judge the quality. And then SLAs, service level agreements between teams, and then obviously KPIs. Well, to me, I feel like I hear this term the most is key performance indicator. So like, is your LLM actually speeding up workflows, or whatever that KPI is for your LLM in production? So it talks about defining those between teams, which again, I didn't really see that a lot in other books. So I thought that was pretty interesting. And then they go into the 4 pillars or goals of LLMOps for them is reliability and scalability, robustness, and then security. So again, also keeping in mind of like not leaking data and stuff like that. Robustness, also some of the stuff like we had talked about, and model evaluation, and potentially data freshness, depending on your application, right? Like all these vary really a lot depending on what your application is. But if you're answering questions on FAQs in your company or something like that, you want to be pulling in the latest data as soon as there's like a new document there. And you could usually do that with things like triggers. So you could have a pipeline that, if you're fine tuning or putting in RAG database, you can have a trigger that looks at like a folder area or something like that. And as something new gets checked in, then you can either, fine tune your model on that new data, or again, this might be like pulling it into a RAG database, and then you chunk that new data and add it to your vector database. Oh, and Elsa said service level objectives. They knew. Awesome. And then chapter 3 was LLM-based applications, using AI models in applications, a little bit about infrastructure applications like MCP, the rise of, this is where they said VLMs, which I think is spelled like the tool, but I think they meant visual language models and multimodal LMs. I've seen a lot of really cool use cases around this too, in like I don't know if it's security and safety. I would say, like, I went to the Embedded Vision Summit this year. There's a lot of really cool use cases. Like, people really want to get a VLM on an edge device, but usually too big for actual edge devices. Maybe not like a Raspberry Pi, but something that's much smaller than that compute wise. And so what they were actually doing is having a lightweight object detection model that you would normally train, like a single shot multi detection model or YOLO or something like that, train on what they wanted to detect. So in this case, it could be like a forklift or something like that going into a zone. Once that happens, then they could take the whole image and send it up to the cloud to a VLM and then get safety predictions back from that. Like, are people wearing hard hats? Like, you can do some of this on lightweight object detection models too, but then they would send it back and then get some extra safety information, which is cool. Like, are people standing in the zone that shouldn't be there, stuff that they didn't like hard code in, or that they didn't train a lightweight object detection model on. So I thought that was really interesting. I'm excited to see like more use cases around this. Having like, I used to work in computer vision, and there's so many interesting use cases that you can use like a VLM for to get predictions out of the box, or more complex things that were kind of harder to put in. The LLMOps question, I forget what that question exactly was. Let me pull that up. I think it was probably just, see, the main question, does the application perform well at a reasonable cost? That sounds like a reasonable question that you should be asking probably most of the time you're putting any machine learning model in production. And again, sometimes these are like trade-offs. So I think that's probably what they are getting to here. It was a while since I read this chapter. But usually you're trying to balance cost and the quality of predictions. And sometimes you have to have super high quality where you like cost doesn't matter. Sometimes you have to balance with being okay with not having the best prediction and then pulling your costs down. Sometimes that's from like making a smaller model that can deploy on an edge device, going back to that example. And you have to have these like trade-offs. Usually you can't usually have like best of both worlds. And they say what you can control in a LLM-based application. So again, we've known that these are kind of like a lot of times non-deterministic like workflows, and they go deeper into prompt engineering here. And then also, I think, like, again, if you need to fine tune or build the infrastructure for that. Chapter 4 is data engineering for LLMs. They talk about like basically different types of data for, I think it was fine tuning for this one. Again, these earlier chapters, it was a little bit ago for me reading. Yeah, I think these ones, I'm just pulling up and looking at the other screen. I don't want to share the book. I don't think I can do that probably for copyright reasons or whatever. They talk about like building the LLM pipeline and then synthetic data as well. And data quality, obviously is a huge deal. I think a lot of people, are figuring that out. And I forget if it goes into it in here. Yeah, I think they do. They talk about chunking and data for RAG as well. One thing, I don't know if they mention it in here, but I always think is really interesting is the tokenization piece too, where you're basically you're cleaning up the text and deciding what text exactly to pass into your LM to make embeddings from, like in the encoding layer. And one thing that's really interesting, I don't know if you've tried to just make some sort of simple tokenization thing on your own, which in production you probably shouldn't. There's really good tools for it. But you have to think about, how do I break up like these words? Like, often engineer is broken up to engineer and then ing. And this saves your space for all your tokens because you can reuse ing on top of other words. And then you get this other word with it. What's interesting is if you break up words in a certain way, or when you're pre-processing the data, you might remove white space. And when you do that, it really changes the behavior that your LLM kind of encodes into it. And a big example why they think that, I think Karpathy said this a long time ago, why LLMs were really bad at coding at first, I think, was how the text was processed and tokenized. So like, if you remove all white spaces into your LM, well, then it's probably not going to have that embedded for Python code, right? And so there's all these weird little things that you want to think about for the data processing, which I'm sure a lot of that's a kind of common knowledge or solved now. But if you're implementing these things from scratch, really interesting to think about. Just like those small changes can really have a big effect on your machine or your LM. then 5 was model domain adaptation for LLM-based applications. So it's talked about training the LLMs from scratch, model ensembling approaches, ensembling approaches, and then model domain adaptation. So they talk about like fine tuning for specific industries, like we mentioned, like a lawyer use case before, and then obviously prompt engineering, because they talk about, that's the low hanging fruit. Again, if you've worked with the LM, you're probably already doing prompt engineering, trying to get it work pretty good on stuff. Then you have model optimization for resource constrained devices. This goes a little bit into, I can pull it up, but I think this goes into kind of like what we were talking about, some of the quantization type of stuff. And Elsa said, also with RAG, they recently found that what was it? Lemmatization, did I say that right? Can also make a big difference. Let's see, how does that relate to RAG? It's a technique that reduces a word to its base dictionary form, called lemma. So I think that's is that what I talked about too, or you're reducing it down to like just engineer? Yeah, there's all sorts of stuff like that, like, or removing stop words that I've had some people put in for RAG, like all these different stuff, like, because in that case you're just pulling up the closest embedding for the retrieval step of RAG, and then it's pulling in data. And so yeah, there's interesting use cases, not just on the fine tuning side, but for RAG like that. I know people who've removed like stop words in there, and like that's a great idea, getting it down to the base word. And then chunking is a big part for RAG too. How do you chunk up the pieces that you want to be returned? And that's something I've been experimenting with a little bit recently on a project again, where I was having issues of getting good chunks. Because again, with code too, you don't want to have the chunk just stop like in the middle of a Python function or something like that if you're trying to return the whole thing for context. And so yeah, a lot of interesting methods there that you can play around with. And really, they should be treated as like another hyperparameter in your overall LM system. And they talk about mixture of expert models. Someone correct me if I'm wrong, but I think is DeepSeek a mixture of expert? Because I think that's how it can fit on smaller devices as well, where you're having kind of basically only key parts of the LM being used at a time to answer specific questions. Oh, and then they also brought up, I hadn't heard of this term. I'm not sure if someone had heard of the term chinchilla model, but that's basically where there's a paper on this. Maybe I'll go find that later and share the link. But basically it's saying like most LMs don't have enough data, or basically aren't trained as much as they could be. So they're like way larger than they are for the data set they have. And the chinchilla model increases the data set to get better results versus just increasing the weights or increasing the weights and data. It's just like focus on increasing the data set. I just hadn't heard that term before. I thought it was interesting. And let me see if I can pull up the paper real quick. Chinchilla model training compute. I think it was this one. Let me share it in the chat, and I'll also note it. And then chapter 6 is API first LM deployment. Talks about building your first API if you haven't done this before, with fast API and interacting with a large language model through it. So developing your API implementation, credential management. So you might need secrets if you're using OpenAI or whatever to do that. API versioning and lifecycle management. Again, this actually might go to Kevin talking about shipping code. So if you're using LM to generate the code, this chapter does cover some of that stuff. LM deployment architectures, automating RAG and retrieval re-ranker pipelines, automating knowledge graph updates. They actually talked a fair amount of knowledge graph in here, which I actually haven't implemented yet, like a knowledge graph RAG, like a graph RAG, which has been on my list to do. And I always think it's interesting. Basically, you can have a graph database Usually it seems like you get good results if you combine a RAG and a graph RAG together, or like a graph database and a vector database together. But basically, you can then have a query where you bring in information like normal RAG, but then you have relationships to other documents and things like that in a graph, which again can be really interesting. Like going back to the lawyer use case, I could see that really being really interesting for cases that relate to other cases that are similar and being able to bring that knowledge in as context. It talks about deployment latency and optimization, orchestrating multiple models. I think Kevin also mentioned this in the chat too, right? Like having multiple models to choose from or get routed to. And then they talk about optimize your RAG pipelines. And this is where they also talk about doing embedding cache. So if you're doing the same queries over and over again, instead of pulling in that data every time, you can have that cached. And I know a lot of the vector databases that have paid services have this as an option. So if you're using like Zillus, which is the parent company to the open source database Milvus, they have like a caching option. So if someone's basically doing the same query or a very similar query to the LM, instead of pulling in that data fresh, you can actually have a cache version of it, which might save you time or cost. And then KV cache is caching the outputs from the model in there. And then chapter 7, like I said, I thought this was interesting. Evaluation of LLMs, I was thinking is an interesting problem. And actually, if anyone has experience of what they've liked to do, that's always fun to hear about in the chat as well. Oops, and I saw. Oh, never mind. I thought there was an error there. And let me actually pull up if people are going to answer that. While people are maybe thinking about that, let me pull up, because I think there were some metrics that they mentioned. Like you might have heard of like Blue and Rouge, different ones for measuring like similarity between question and responses. They mentioned some I hadn't looked at, and I think there's a ton of these, and I don't know which ones are going to always work well for you. There's G eval, which I hadn't used before, uni eval, GPT score, true, self-check GPT, a whole bunch of these different ones. And I think there's more frameworks coming out all the time for just open source ones or more professional logging ones you might use in production. Again, Arise and like Weights and Biases Weave are two of the common ones I see all the time. There's also like Arthur Fiddler, a whole bunch of other ones. Evidently? It's another open source one that I think was interesting. But also, like I was saying, it depends on what you're doing. Like it says traditional metrics aren't enough. That's often true. But if you are doing like classification problems, obviously, then you can potentially use those metrics. But there's other metrics too that you might want to think about when you're doing just stuff out of the box or getting started. Things that I've found really helpful in the past, depending on your application, is using either like you can take some BERT models now that are good at this, or in like the NLTK library, which is like the older NLP library you might be familiar with. There's a lot of other kind of out of the box metrics that you could use from there that could be interesting over time. And if you don't know what to measure, you can kind of start with like a shotgun approach, use a whole bunch of them, and then get rid of them over time if they're not valuable. But for example, you could take something that does like a sentiment score over time, and that can be a metric, just sentiment overall. Like you're not seeing the entire text or input output, but if you're just monitoring like a sentiment score over time in like a line chart, if all of a sudden like the sentiment gets really negative on either the input or the output of the LMs, that could be an indication of something. Like, and if you're changing prompts and stuff like that and not really or you might even be evaluating, but in production data can look different. So like just these little metrics like sentiment or word count or things like that can actually give you some insight of like, did something change and maybe it's going wrong to your LM, or your customers behaving different. So there's all these different little metrics that you could start out of the box and then see if they give you insight. I like sentiment and seeing like, why is my large language model being really mean now? Or can you correlate that with like the input being mean, stuff like that. And then also they talk about guardrails, which I kind of lump into monitoring as well. Sometimes depending on what the guardrail is, but like monitoring for outputs for PII or things like that. Like I've told the story before, but if you haven't heard it, it's like I was helping with a chatbot and there's like an angry customer for the storefront. and it said, "Oh, like, yeah, I'm really sorry," and it gave the customer a phone number, but it just made up the phone number. There was no phone number it actually should, give out. So we only caught it because we had, like, a pattern matching saying, anytime there's a phone number, that just gets logged in this, like, line chart, and then you can go, debug and see what happened, and so you can look at the input and output, and it's just, like, stuff like that is important to have potentially. It, again, depends on your application. And someone said, "Oh, so can you post that evaluation metrics?" I'm not sure which metric specifically you were talking about. So there, maybe it was but there's like libraries that actually. So this, I'm not sure if it's being updated anymore, but there was a library that I worked on called Linkit. That I haven't kept up to date to see if that library is still being maintained, but it had out of the box metrics we talked about, and then you would use or you could use like an LM or something as well if you want subjective monitoring. So usually right now, people like I like having these like metrics to pull out. They give me some sort of insight into stuff to see what's going on, even if I'm going to use an LM as a judge later on. So it said in this context, how are we evaluating the LM by efficiency and time per query, cost per query, accuracy, compliance, risk, something else. So I think they talk about all these things, or at least in some of the other chapters. A lot of this is more on the accuracy type of performance or giving you the correct response, but they do touch on also monitoring for like latency. I think in one of the other chapters a little bit more than the evaluation, but you should be monitoring probably for your latency, efficiency, if that's something that you need to think about for your application. Oh, and I see someone else answered the chat for this one. Yeah, the evaluation. This specific chapter, I think, is on the relevance to the response, but they talk about those other things in other chapters. Oh, someone said the names before, so I think or someone said the names that I said before for the LM metrics. So there's I'll throw out I think the ones that I was saying. So I forget if how is blue spelled? Is blue is a common one. Rouge, oops, rouge. Am I spelling that right? These are you if you look that up and then say ALM metrics, I'm sure it'll show up. And then the ones that were mentioned here that I haven't looked at as a G eval says it scores the generated text based on its coherence, fluency, and factual consistency as judged by another LM. So this does use a this one uses an LM as a judge. Actually, I think a lot of these ones they link to might, but it's kind of a framework um, around using another LM as a judge. That makes sense. This one's called GPT Score. You're probably using GPT to score it. And there's one called True, and then Self Check GPT. Those are the I think all the ones I mentioned before. And it does seem like the common thing right now is if you're getting responses that are subjective back from your LM, that you're likely going to want some sort of LM as a judge later, which I know is interesting too, because then you have another LM, and it's like who's monitoring that LM. So I think in combination, it's using like the metrics we talked about to get some insight, and then LM as a judge, and then you manually validating some stuff sometimes. And I asked, is Lang chain or sorry, Lang Smith the gold standard for monitoring and observability these days? So I would say Lang Smith comes up quite a bit. Um, I don't know if it's a gold standard. I haven't actually used it recently. I think I looked at it when it first came out a long time ago. I think it's very different now. They've rolled in like LangGraph Cloud to Langsmith now. It's like a whole ecosystem around LangChain and LangGraph stuff. You have Langsmith, and then I would say I see a lot from Arise. So if you haven't looked at them, check them out. And then also Weights and Biases. They have a product called Weave, which I've played with. Both Arise and Weave are really good for basically doing traces and like having a monitoring dashboard set up. Also, you can come up with your own metrics, um, decently I want to say somewhat easy. And like, again, if you're using something like Flight, you could track those inside your orchestration layer. I think it's actually that's something I'm experimenting with more because I think it could work really good. And let's see, we're on 7. I'm gonna go through. We're almost at time actually. Um, the other chapters at 8, governance, monitoring, privacy, and security. So a little bit more on monitoring here, but this is a little bit more about kind of what I talked about actually, catching like the phone number leak, for example, setting stuff up like that. There's a whole kind of area which I'm sure is going to boom in the next several years, like LM security ops. If anyone's like looked into that more, let me know. I haven't a ton, but obviously very interesting from like the data that can leak. Can people steal your models? All sorts of stuff there. Actually, I think I grabbed this because I thought it was interesting. They link to the NIST framework. Share the link to that here. And then chapter 9, this is on the scaling hardware infrastructure and resource management. This one, they talk a little bit more about monitoring for um, latency and stuff like that. Choosing the right approach, scaling and resource allocation, monitoring, A/B testing, shadow deployment. Always something I really like doing, even before large language models, is shadow deployment for an updated model. That's like you would have a new fine-tuned one, or even a new prompt. Maybe it's not a fine-tuned model, but you want to see how that behaves in production, so you can actually run it on production data, see what the responses are. If you have a monitoring system, you can be monitoring that as a separate project, and then compare that to the model that's actually giving a response to production before you like ship it out. So really good way to experiment, especially if you think it's risky, is something like shadow deployment. Automatic infrastructure provisioning management. So they talk about Kubernetes. Kubernetes is a really great way to scale up environments and make them very reproducible. If you haven't used it before, you should check it out. And then I had already shared the link to Flight. Flight's built on top of Kubernetes as an SDK that makes it really easy to manage it. And then you get the stuff out of the box, like every single workflow version is run, so it's easy to debug, and you have caching and stuff like that. So Kubernetes with all the stuff you would want for large link or for LLMOps and MLOps. Optimizing LM infrastructure, parallel and distributed computing for LMs. And then they talk about some frameworks here. I actually hadn't heard of the framework Zero, but it sounded like it's actually what Deep Speed became, which I have heard about. It's a framework from Microsoft. I can pull that up too, actually. Deep Speed. Oop, as I hit a shortcut that stopped sharing my screen. Cool. I think we're back. Deep, Deep Speed. I think it's an open source one. Grab the link here. Yep. And I'll put that in the note slide. And then the last chapter was the LMs, or sorry, the future of LMs and LLMOps. They talked about thinking there's going to be more of the mixture of experts. So, like I was saying, I believe that's one of the things that DeepSeek does. Probably true. And then they also are really bullish on knowledge graphs. Like I was saying, sounds really interesting. I need to play around with that more. If you're looking for a graph database to get started, I know Neo4j seems really good. I am probably going to try building something with them. Also, Llama Index has some cool graph stuff out of the box as well, I believe. So if you don't want to use like another database, they might use Neo4j under the hood. I'm actually not sure, but they have a nice SDK for getting graphs. Which actually I think I've done that a long time ago when I was playing with Llama Index, but not anytime recently on an actual project. And that's the book. Obviously, there's way more in the book. We just had a conversation around some of the topics here. I'll share the link to it again if you want to go check it out. Um, Always recommend supporting the author. They actually mentioned they wanted to come on. I don't think the timing worked out since I already had this booked at this time, but they might come in and do a talk or something. So if you have questions for the author, let me know in the Slack channel or something later. And if they do come on, that'd be cool, and we could ask those questions that you might have for them. And don't forget to let me know what book we should read next as well. Oh, and then I think I missed chat. So it's at API World, which I assume is a conference or something. That sounds cool. They mentioned many enterprise APIs overshare information in the responses. In the responses can lead to compliance and security issues to LMs who are always stitching together information. That makes sense. So thank you. Yeah, thank you for coming and talking in the chat. It's way more fun, obviously. The only reason I was saying, like, I always think, oh, I could end early or whatever, but there's always awesome, really good questions and conversations going on, even if it's just in the chat. So hopefully you enjoyed the discussion around it. And thank you, everyone, for talking in the chat. Go check out the book. Also, I usually read on the online O'Reilly platform, which if you have, like, you can get a lot of times through libraries and university. I think there might be a limited platform, or like they might not have every single book in there that's on the paid one, but I think they have most of the O'Reilly books, at least. So on the paid one, they have like all the stuff for Manning and Pact as well. But if you're looking for access to these books, a lot of times you can get the O'Reilly platform through something like a university or library. So check out the library, or if you have a university account, see if you have access to it. If you don't, and I will share the Slack link one more time too. So again, if you want to join a discussion or start a discussion around the next book, which is again going to be the deep learning for biology, which I don't work in that field, but I actually have a fair amount of users of Flight or customers of Union AI that do work in the biotech field, and I'm kind of interested to dive deeper in there. And it's fun going into a domain specific field and like diving deeper about how they're using AI. So I'm kind of excited about that. I don't know if anyone else is excited for it. I could share the link to that real quick too. Let's see, biology. I don't have the link ready, so give me a second here. Then we'll stream. And the event is already up there, so if you join the Luma or found this on Meetup, it should be there. And this is the link. Oh, someone said they like one of my stickers, which is the push prompt pray. I didn't make that. Actually, I was in San Francisco a few weeks ago, and someone said, "I have some stickers for your sticker wall," and gave me some of these stickers, which are really good. Push prompt pray, which also I think if you go to and maybe I'll pull up the URL. It says singularity.supply. I'm not sure if they actually have if you can buy these. And also the flibberty gibberty, which is something I think that Claude Code says when it's like thinking. And oh, they also had this strawberry, or there are two R's in strawberry. They had some really good like meme worthy stickers made, and they said these are for your sticker wall. So I put them up. Let me see if the URL works. Uh, oh, dot supply, not supplies. It's like this doesn't look right. It's showing me like bolts and nuts. Oh no, it doesn't look like it's an actual site right now. But yeah, shout out to them. All right, so I'm gonna wrap up the stream. Some other work I got to go do. Stay connected on Slack. Connect with me on LinkedIn, and hopefully I will see you all again at the next book club or the one after that. And again, if you have recommendations for what we should read in 2026, let me know. I'll talk to you all later.